Assalamualaikum and hello everyone. Welcome to the video for 3.2 Nernst equation. In this video, we will learn to use the Nernst equation to determine the concentration or the partial pressure of the species as well as the equilibrium constant when Ecell is equal to 0. So on your notes, you'll be on page 10. Okay, so here for number 3, equilibrium constant. So this is actually when there is no net reaction occur, so the Q will be equal to K. So here is actually the original Nernst equation where Ecell is equal to E naught cell minus 0.052 divided by N log Q. So when there is no net reaction occurs, so Q will be replaced with K. Okay, and then the Ecell will be equal to 0. So when we substitute the K and 0 here, and then we only have this equation. And when we substitute it, this is the formula that we can use to calculate the equilibrium constant, which is your K. Okay. So here there are 2 examples, so let's do the examples together. Okay, so determine the K, so we will use this formula. E naught cell is E naught cathode minus E naught anode, and it's actually the number of electron gain or lose during the redox reaction. How do we know the number of electron? Because in the equation, it's not given. So we have to write down the equation of the anode and cathode. Okay, so remember that anode must be the negative, cathode positive. So here we know that the copper is the anode and the silver is the cathode. So let's write down the equation. At anode, okay, what happened is that, okay, the first one is actually our copper. Start with our copper solid. And at anode, actually oxidation where you will lose electron. So we're going to write down arrow, so Cu2 plus 2 electron. Make sure the equation is balanced, the atom as well as the charge itself. Okay, so once we have checked it is balanced, we can continue with the cathode. Okay, so for the cathode, it's actually starting with the argentum. But do we have to include 2? Okay, we're just going to include the species only. Cathode is actually a reduction process where we will gain electron. Okay, so gain electron here. So this is actually the product, and then check the equation where it has the balanced atom and charge. Okay. But however, we could simplify this equation where the electron must be the same. But now, the electron here is not the same, so the cathode must be multiplied by 2. So when it is multiplied by 2, so we know the same electron is actually N is equal to 2. So then we can substitute into the formula straight away. Okay, so again, the E naught cell is E naught cathode minus E naught anode, or kakak tolak adik. Okay, kakak is actually the more positive, adik is the more negative. Okay, so we can substitute it straight away. So we know that the value is equal to positive 0.46 volt. Okay, so we can substitute straight away into the formula. So E naught cell is equal to 0.46 equal to 0.0592 divided by 2 log K. Okay, so from here we can substitute, we can calculate it. Then we know the log K is equal to, the answer is 15.5405. So to get the K, we must anti-log the value. So our K will get 3.47 exponent 15. So that is actually the examples. Okay, the formula is quite straightforward, but then still, how to use it? First write down the formula, then you still have to write down the equation anode and cathode to find your N. Okay, so that is the start for you to try yourself for example B. We have learned about the equilibrium constant, how to use the Nernst equation to find your K. Okay, next is actually we will use the Nernst equation to determine the concentration or partial pressure of the species. So again, let's do the examples together. Example A. Okay, now let's look for example A. So here is the information given. So the concentration of hydrogen ion is our unknown. Okay, so here is the cell potential, positive 0.7. But is it Ecell or E naught cell? But since the definition does not have the standard itself, so it means that this is my Ecell. So when we use Ecell, we have to calculate it using Nernst equation. Okay, so again, when you use Nernst equation, first write the formula, second write down the equation to get your Q. So how to get the equation is from this cell notation which follows the ABC rule. So I'm just going to denote this is A, rich, and cathode. Okay, next what we have to do is we have to write down the equation. So for the anode, what we're going to write down is the zinc first, and then because anode oxidation lose electron oil, so we're going to write down it will lose electron. So make sure check that the equation is balanced, the atom as well as the charge. Okay, the atom is balanced 1:1 ratio. Okay, and then when you check the charge is balanced as well. So next we will continue with cathode. Okay, so for cathode, it is H plus equals, but since cathode is reduction where it gain electron, break, so it means that we have to gain electron to form H2 gas, the product. And then we have to check the equation is balanced. Since the hydrogen is 2, we have to add 2 in front of H plus, then you will have 2 electrons as well. Because later we will get a balanced charge. Okay, so that is the equation. Next, we have to do the overall equation, which we will simplify the equation by simplifying the electron, which must have the same value. So, what I can do is actually, we can simplify it. I'm just going to write down again the reactant as well as the product itself. And then make sure this is my Q. So we can use the formula again. Okay, so for the formula, remember the Q itself is actually Q is equal to product divided by reactant. And it is only applicable for gas and aqueous. Okay, so for the product itself, both is aqueous and gas. So it means that both is written down. Okay, so for aqueous, it is concentration, so we have to write down the square bracket. But gas is a pressure, so you don't have to include square bracket. It's actually a regular bracket only. P stands for pressure. Divide by the reactant. Okay, reactant here, we have solid, so it's not included. H plus equals square bracket again because concentration. But then we have 2 here, so we have to write down to the power of 2. Okay, so that is the formula. Okay, so the unknown concentration is our H plus. So it means that all of this, we will have the value itself. So what I'm going to write down is actually, I'm going to write down and list down all the value for Ecell, E0 cell, and N, and the concentration. For the E0 cell, it's actually cathode minus anode or kakak tolak adik. Okay, so how do we get the E0 cell? Okay, it's actually given here, the E0. Remember, cathode must be the more positive, anode must be the more negative. Okay, so I'm just going to label the cathode and anode, and then we can substitute it straight away. Okay, so for the cathode itself is actually 0.00, and the anode is negative 0.76. So this is actually the value itself. Okay, and we have found out from our equation itself where electron is gained or lose. So the electron is actually 2. So we have to write down N equal to 2. The concentration is given from the cell notation as well as the pressure of H2. Okay, last but not least, the H plus is our unknown. That is the question. Okay, so from here, we will substitute it into the formula straight away. Okay, so here I'm just going to copy paste it. Okay. So make sure substitute it with the correct one. So Ecell, our Ecell is 0.7, E0 cell is 0.76, minus 0.0592 divided by N. Our N is equal to 2. Okay, and then just gonna write down again with the correct color. So just to make it clearer to you. Okay, and divide by the log of 1 over x squared. Okay, so here is my x, but please include the square as well. Okay, so this is actually the value itself. So here we get negative 0.06 equal to negative 0.0296 log of 1 over x squared. Okay, so from here, 0.0296, actually we have to divide it. Negative 0.06 divide by negative 0.0296. So we get this value. And then to remove the log, we have to anti-log 2.02702. So we will get the value to be 106.4192. So again, just take 4 decimal places first. Okay, and then so this is x squared, but then H plus, we denote it as x. So we have to find our x. So the x is equal to 0.096 molar. Okay, so that is actually the solution. Okay, so it's quite a long step, but then again, remember for the Nernst equation, first step, write the formula. Second step, write the equation to find your Q. And then the third step is actually extract the information so that you can find your question. So that it is easy lah to find your question itself. So this is the step. Okay, so for question B and C. Okay, B and C is the same as question A itself, because for B and C itself, when you look at the question, here they ask for the concentration, here pun ask for the concentration. So it is the same step. Okay, so for question D, they ask for the pressure, but then again, the cell notation is given, so it's the same step as previously. For question E itself, the cell notation is not given to you. But then how do you measure? How do you determine which one is anode, which one is cathode? Can be determined from the E naught value, where the cathode must be the more positive and the anode must be the more negative. So in this case, my cathode is plumbum, my anode is aluminum. So I'm just going to label that the cathode is the plumbum and anode the aluminum. So question F, now we can do it together. So here is all the information given on question F. So let's extract it together. So here is standard cell potential. So standard cell potential is E naught cell. So it's actually positive 0.34 volt. Okay, and then this is but how about 0.53? That is the cell potential. So cell potential is E cell. We don't have any naught. So when we have E cell, so you know that you have to use the Nernst equation. This equation you have to use. But then again, what about the question? The question asks to of pH. Okay, what is the formula of pH? pH is actually negative log H plus. So it means that we have to find the concentration of H plus, which is unknown. So we have to find the H plus first, then we can find the pH. Okay, so when we use the Nernst equation, first you have to write down the formula. Next, write down the equation to find your Q. Okay, so let's write down the equation. So here is the cell notation which follows the ABC rule. Okay, so I'm just going to write down the equation. We started with anode. So anode is actually my hydrogen. The platinum is the inert electrode. Inert electrode again is not does not involve in the reaction, so you don't have to include it in the equation. So I'm just going to be focusing on the hydrogen itself. So again, the reactant is H2 gas. Oxidation is losing electron. So we will lose electron. We will form H plus electron. So check whether the equation is balanced. Check the atom as well as the charge. So the atom is not balanced, so we have to add 2 H plus here. Then we balance it with the electron. Okay, and then we get both sides is 0. So next we can continue with cathode, which is the copper. So the cathode started with Cu2 plus equals here. And then for the cathode, because the cathode is a reduction process, and reduction is gain electron. Okay, so plus 2 electron to get Cu solid. So again, once you have checked it, okay, so you can simplify the equation by cancelling out the electron, which the electron must be the same. So I'm just going to write down again all the equation, the reactant on the reactant side and the product must be on the product side. Okay, so since this is the equation, then we can find our Q. Okay, so again, what is Q? Q is actually product over reactant, which only consists of the gas and equals. We only consider it. So for the product, only consider H plus to the power of 2. And then the reactant, gas and equals. So we have to consider for both. So since that is the pressure, gas, we have to write down P. Concentration must be a square bracket. Okay, so this is actually the formula. So the H plus, that is our unknown. Then we can find the pH. Okay, so right now I'm going to write down is actually I'm going to extract all the information so that it's easier for us to substitute later on. Okay, so Ecell and E0 cell, N is where the electron is gain or transfer, or gain or lose, which is N equal to 2. Concentration of H plus is the unknown. The pressure of H2 is given from the cell notation, 1 atm. The concentration of Cu2 plus is given as well, which is 1 molar. So this is all the information based on the question itself. Okay, so the H plus is our unknown. So let's do it together then. Okay, so here I will substitute all the values where the Ecell is equal to 0.53 volt. The E naught cell is positive 0.34 volt. Okay, and then the N is equal to 2 because the electron gain or lose or the electron transfer is 2. Okay, and then we have to include the concentration and the pressure. Okay, so this is actually all the value. So let's rearrange it so that we get our X. Okay, so first is actually 0.53 minus 0.34, and then this is the value that I will get 0.0296. Okay, but then if I copy paste it here, but it is the same as log x squared, because x squared divided by 1 is the same as x squared, kan? So we will just let that be. So we get log x squared to be, the value is tunggu sini, negative 6.4189. But then to get the x squared, we must anti-log the value. Okay, this is only the x squared. Again, we want the concentration, which is the x. So we get 6.1737 exponent negative 4 molar. This is the concentration of H plus. But the question asks for pH. So again, what is a pH? pH is negative log H plus. So negative log of the value itself. Okay, so this value, we will get the pH is equal to 3.21. So that is the step. So it is the same step as previous one, but there's the extra step is actually when you find out the H plus. Okay, so because from the H plus, find your pH. Okay, so for the hydrochloric acid, why do we get H plus? Substitute straight away because HCl is equal to H plus plus Cl minus. Okay, so that's it for this video.